Hello everyone, let's talk about special relativity in modern physics. Special relativity is the branch of physics that describes objects moving near the speed of light. The reason for special relativity is that classical laws of physics cannot accurately explain the relations between reference frames when objects are moving near the speed of light. So let's first talk about inertial reference frames, as this concept is crucial for understanding relativity. An inertial reference frame is just the frame of reference of an object, where we'll pretend it is not moving or accelerating. This is best described by an example. So consider the following scenario. An observer on the ground is stationary, while one plane is moving at 300 kilometers an hour and the other plane is moving at 400 kilometers an hour in the same direction. In the stationary observer's reference frame, the first plane is moving at 300 kilometers an hour and the second plane is moving at 400 kilometers an hour, as you would expect. But if we were to switch to the first plane's reference frame, it would appear that plane 1 is stationary, plane 2 is moving at 100 kilometers an hour, and that the observer on the ground is moving at negative 300 kilometers an hour. This is because we are assuming that the first plane is stationary since we are in its reference frame. Then, if we were to look at the second plane's reference frame, it would appear that plane 2 is stationary, plane 1 is moving at negative 100 kilometers an hour, and that the observer on the ground is moving at negative 400 kilometers an hour. Moving on, Albert Einstein derived the theory of special relativity from two postulates. The first postulate of special relativity says that the laws of physics are the same for all inertial reference frames. The second postulate says that the speed of light is the same for all inertial reference frames. These postulates might be a little bit confusing at first, so let's try to explain what they actually represent. Let's consider the following example. There are two spaceships flying by Earth. The observer in the first spaceship is moving at 3/4 the speed of light, while the observer in the second spaceship is moving at half the speed of light. And let's assume that the observer on Earth is stationary. I know that the Earth has rotational velocity, but let's just assume that it's negligible compared to the speed of light. Now let's say observer 1 turns on a flashlight, and they measure the speed of light to be 3 times 10 to the 8 meters a second. Then observer 2 measures the speed of light emitted from the flashlight, and they also measure it to be 3 times 10 to the 8 meters a second. And then observer 3, who's stationary, also measures the speed of light from the flashlight to be 3 times 10 to the 8 meters a second. But they are all traveling at greatly different speeds. So why do they measure the speed of light to be the exact same? Well, it's just a fundamental law of physics that the speed of light is constant, no matter the reference frame. And although that might not sound very convincing, it's just how the universe works, and we have verified this several times with highly precise tests. The outcome of this is that time must be passing differently for the different observers. If you are struggling to understand this concept, I don't blame you, as it certainly goes against our classical thinking. My advice is to just accept that it's true and roll with it. So, special relativity is a theory that describes the relationship between space and time. This introductory video was more focused on the concepts of relativity. In the next few videos, we'll start jumping into the equations and the mathematics.